Hi, Algebra 2 students. It's day 8. It's the last day of new notes in our Unit 3. Right? So we are looking at application of linear systems with 3 variables. So we did yesterday all the practice with just how to solve them. Today, same practice, but we have to set up the equations using the word problem. So the first one is saying, a restaurant owner estimates that she needs in small change the same number of dimes as pennies and nickels together, and the same number of pennies as nickels. If she gets $26 worth of pennies, nickels, and dimes, how many of each coin does she have? All right, so a couple of things. We have to set up what are our variables. Now, you can always default to X, Y, and Z. Otherwise, sometimes it's nicer to use different variables so that it's easy to remember which is which. So like we could use P to represent the number of pennies, and then N to represent the number of nickels, and D to represent the number of dimes. Okay. When you read through it, I almost made a mistake reading it this first time here. You have to read really carefully. It's saying she needs in small change the same number of dimes as pennies and nickels together. So from each little statement here, we should be able to come up with an equation. So same number of dimes as pennies and nickels together. So if we think about pennies and nickels together, we're adding however many we have, and that should be the number of dimes. There's our first equation. She needs the same number of pennies as nickels. So number of pennies has to equal the number of nickels. That little equation right there, that's equation 2. If she gets $26 worth of pennies, nickels, and dimes together, how much of each coin would she have? So in this case, what you have to think of is not how many she has, but how much it's worth. So I can't just say pennies plus nickels plus dimes equals 26, because that's implying that there's 26 coins. I want the worth of the coins to be 26. So in that case, you have to multiply it by how much each coin is worth. So every penny is worth 0.01 of a dollar, every nickel 0.05, and then every dime 0.10. Right? So that's going to become our third equation here. All right. Now, if you want to use elimination method like we did before, what I would suggest is you have to get everything on one side. So like this would be P plus N minus D equals 0, and then P minus N equals 0, and then you'd have this. Otherwise, if a question presents itself in a way that maybe substitution works better, you can use substitution. So I actually like in this one, since we know P and N are equal to each other, we can substitute one in for the other. So in this case, I would say let's use substitution, right, to get an entire equation either in terms of P or in terms of N. So you can use either. If we were in class, I'd probably say, which would you guys prefer? But since you're not with me, I'm going to pick. So let's use substitution to get the entire equation in, let's say, terms of P. All right, let's get everything in terms of P. So what that means, all right, is in the top equation, I use my red pen to kind of distinguish, wherever there's an N, I know that N is the same as P. So I'm going to sub in P for it. So what this really means is that I have P plus P equals D, or I can make this 2P equal to D. All right. Why that's going to be helpful is I'm going to use this big old equation right here, and I'm going to try to get that entire thing in terms of P. All right. Well, that means I'm going to do a double substitution. So the first part, this already is P right here. I don't need to mess with it. I need to sub in for the N, so I can have that in terms of P, and I'm going to sub in for the D. And what I have are values right here that I can work with. So this is going to be 0.01 P, 0.05 in place of N. Since N is the same as P, I'm going to put that here. And then plus 0.10 in place of D. Ooh, here we go. I'm going to put that in. So I'm going to have times 2P like that, and then equals 26. So we use substitution. So we substituted in here, we kept that guy. All right. Now we have everything in terms of P. This is just a basic old linear equation. So let's add some stuff together. That's going to give us 0.20p. And then when we add everything on up, so 0.01 and 0.05, so that's going to give us 0.26p equals 26. So that's not too bad. All right. In case you are afraid that mental math wise that this would mess you up, grab your calculator. You're going to divide both sides by 0.26. This is one of those ones where you would be moving the decimal, and p comes out as 100. Right. So that's the number of pennies that we should have. So when we say p is equal to, that's the number of pennies. All right. Now let's work back. The number of nickels has to be the same as the number of pennies. So we need to have 100 nickels as well. And then the last one, we were able to solve for dimes as being double the number of pennies. So if we double the number of pennies, there should be 200 dimes. All right. Last thing, oops, I'm so sorry. I'm a little off the page there. Last thing is we want to stop and think, does that make sense? So we always want to check the answer. So in this case, if we have 100 pennies, that would be all of $1, all right? Because if we go 0.01 times 100 pennies would be $1. And then 0.05 times the number of nickels, all right? If you have 100 nickels, what you really have is you've got $5. If anybody's ever rolled change before, you kind of might be aware of some of these things. And then the last part, for each dime, it's worth 10 cents, and you have 200 dimes. So 200 dimes, if I take that product, that's going to be worth $20. So altogether, there's your $26. So when it says how many of each coin does she have, you can leave it like this since we said the let statements up top, or you can write it out that you're going to have 100 pennies, 100 nickels, and 200 dimes. There we go. All right. That's the first one. We only have one other question that we're going to be looking at for today, and we're going to flip it on over to the back, and you're going to write it down. Now, I say only one more, but it's a little involved, but that's okay. So flip over to the back where it's a completely blank page, and we're going to write the question down. So copy carefully with me. So for example number 2 today, what I want you to do is I want you to find the equation of the parabola, I feel like I made up a spelling there, parabola, there we go, looking funky. All right, let me move my calculator out of the way, in the form of y equals ax squared plus bx plus c. So our final answer, we're going to be able to write it out like this, given 3 points that you know are on the parabola. So given the points, 1, -11, -2, 13, and then 3, 3. So find the equation of the parabola in this form, given that the points 1, -11, -2, 13, and 3, 3, I should say all lie on the graph. Or maybe I should say lay on the graph. I don't know. It looks weird as right lie. All right. Either way. So how do we do this? Well, just like the last problem, we don't have any equations. So we have to be able to create equations here. Now, what we don't have to do is we don't have to create what variables we're looking at. Because if I want the equation in this format, the variables that we need to do or that we need to come up with are A, B, and C themselves. All right. So what we're going to do is our goal is we're going to solve for A, B, and C by plugging each XY point into the general equation. All right, and I know my handwriting gets a little scribbly, so hopefully you can read that. Solve for A, B, and C by plugging each XY point into the general equation. So let me walk you through what I'm talking about. So over off to the left, let's put the first point, 1, -11. So the X is 1, -11 is the Y. Let's plug that into the equation, meaning in for Y right here, we're going to put -11. We keep A, in for x, we put 1 and square it, plus b, in for x, we put 1 again, and then plus c. So that's the first thing. Now, we're not going to leave it like that. We're going to clean it up. So when we clean this up, what we really end up with is negative 11. A times 1 squared. Well, 1 squared is just 1, so we get 1a, or plain old a by itself. This would give me 1b, so plain old b by itself, and then plus c. All right, let's do that for the other 2 points. So the next point is negative 2, 13. Remember, x, y, so 13 goes on the left. A times x squared plus b times x plus c. When you clean those values up, 13 stays. Negative 2 squared is simply 4, so that is 4a. The product here would be negative 2b. Oops, let me adjust that because I want my equations to look perfect so I don't confuse anybody. All right, so minus 2b and then plus c. All right, we have one more point. It is the point 3, 3. So it's a little forgiving because your x and y are the same. So you're plugging 3 in here, plugging 3 in here, plugging 3 there. Okay. When you clean up that equation, we get 3. That would be 9a plus 3b plus c. So all of this turns into this. So here is our system. On the notes from day, what would that be, day 7, we labeled these equations as A, B, and C. We can still do that, maybe using capital A, B, and C to keep track of them, but that is only if you feel like that's something that you need. If you feel like you can walk through the problem and you don't need those extra labels, then you can avoid them. So what I would want you to do here is look and say, okay, I'm going to solve a 3 by 3 system. It's more like a traditional one, so using elimination makes sense. You want to think about which variable is the easiest to get rid of. Would it be the A, the B, or the C? Now, technically, you can do any of them, but to me, the fact that all the coefficients on C are 1, that's going to be the easiest thing to get rid of here. So our goal to solve this is let's eliminate C so that it's A and B only. All right. To keep it simple, I'm just going to pair up the first 2 equations. So I'm going to use equation A and use equation B. And to eliminate C, since they're both positive C, I'm going to have to negate one of the equations. So maybe I'll negate the second one. All right. So copy the first one exactly as is, negative 11, and then A plus B plus C. And then take the second equation and let's negate the whole thing. So negative 13, negative 4A, positive 2B, and then negative C. Let's add these guys together. All right, negative 11 and negative 13, that's going to give us negative 24. A minus 4A would give me negative 3A. B plus 2B is going to give me 3B. And then my C's eliminate, which is exactly what we wanted. All right, let's repeat that process one more time. Because we already combined equations A and B, you can now do A and C, or you could do B and C. It doesn't really matter. I'm going to choose to do B and C here. So I'm going to play the same rule where I'm going to keep the first one as is. So 13 equals 4A minus 2B plus C. And I'm not going to negate the second one. So negative 3, negative 9A, negative 3B, and negative C. All right. Remember, the reason we did that is because we need to eliminate the C variable. So when you add this together, 13 minus 3 is now 10. This would give me negative 5A. That's negative 5B, and there goes the C's. Okay. Now, you don't have to have it in a separate color, but sometimes it just really helps you refocus. At this point, once I am down to a 2 by 2 system, I ignore everything above it, and I am solving this 2 by 2. So it's kind of as if I just handed you this fresh problem and we go from here. Now, there's a lot of ways you can do this, but if I look, the A coefficients, I've got negative 3, negative 5. With the B, I got essentially the same thing. I would have to multiply both equations by a number. something that we can do here is rather than multiplying both equations by a number, you can also make the argument that you could divide both equations by a number. So if you look at all the coefficients here, you have 3, 3, and then your constant is 24. These are all divisible by 3. So rather than multiplying by 5 and making the numbers big, I could actually do the reverse if I want. And I could say, let's bring this down and let's divide everything by 3. And I'll show you how this is going to work really nicely. So negative 24 divided by 3 would be negative 8. Negative 3 divided by 3 would be negative a. 3 divided by 3, that's going to be plus positive b, right? And now if I do the same thing over here, not so much that I'm going to divide by negative 3, but look at what you can divide everything by. Those are all divisible by 5. Let's divide everything by 5, which then makes the 10 turn into a 2. That would turn into negative a, and this would turn into negative b. Now, what I didn't even look at ahead of time was which variable was going to cancel. I could have been a little bit more direct about it, but I knew that these were opposite signs, and as soon as I brought them down to a single b and a single b here, that they would be set up nicely to cancel one another out. So let's add this together. Negative 8 plus 2, that is going to give us, just making sure I copied correctly, that's going to give us, here we go, negative 6. And then negative a plus negative a gives me negative 2a, and there goes my b's. All right, we are set up to solve for a. So when you divide both sides by negative 2, a comes out to be positive 3. All right, one variable down. Stick with that little system. Now you can plug into either one of the red equations that are circled or into one of the simpler equations. Either is perfectly fine. So if you're like, these simpler equations look easier to use, then use them. So I could say, negative 8 equals negative 3 plus b. So I'm using that first equation right here. And then this would come out by adding 3 over, and b would land at negative 5. All right, 2 variables down. Once you get 2 variables down, you've done what you can with this little system. Now we have to go back to one of the original equations back up here. So you can plug back into A, B, or C. It does not matter. I'm going to plug back into A, partially because it's the simplest one that's up there. So when I plug back into A, which is negative 11 equals A plus B plus C, when I clean this up, here's negative 2 plus C equals negative 11. Last step, add this on over, and we get negative 9 for C. Okay. I have to do 2 more things. I first have to check, make sure that I didn't mess anything up. So I said to check, you have to plug into the equation you didn't use here. So if I used A, then I'm going to plug into B or C. So I'm going to pick B and plug my values in. So 4 times A minus 2 times B plus plain old C. Let's see how this goes. We get 12. Double negative turns into plus 10 and then minus 9. So 22 minus 9. Yeah, that's going to be 13 right there. So that's the first thing. We did a good job. We got it. But this question's a little bit different than the ones before. So we don't just write the answer in alphabetical order and go 3, negative 5, negative 9. Come way back up to the top. It says find the equation of the parabola in this form. So it's y equals ax squared plus bx plus c. Let's write down our equation. So y equals ax squared plus bx plus c. And now here should be our final answer. One thing that's cool about a question like this is you can actually use your calculator to now check it. So if I go into my y equals right here, I'm going to type in the equation we just came up with. So 3x squared minus 5x minus 9. I can type that in. And then I'm going to go to my table of values, and I'm going to check and see if those 3 points are there. So I'm going to zoom in a little bit so that you guys can see better. And so the points that we had from the start were the points negative 2, 13. So there's that guy right there. We had the point 1, negative 11. There's that one. And then 3, 3. There we go. So we can feel absolutely confident that we came up with the correct answer there. All right. Nice job. Make sure that you go and answer the post-video question. I'll see you guys in class.